Today we will see the second part of module 5, that is gear trains. So as you all know, gears are mainly used in transfer of rotary motion from one shaft to the another. When you want to get a wide range of angular velocity ratio, it is often necessary to combine several gears. It may be combination of spur gears, it may be combination of different types of gears. So any combination when you do to form or to achieve different angular velocities, we call it as gear trains. A gear train is two or more gear working together, meshing their teeth and turning each other in a system to generate power and speed. Any combination of gears being employed to transmit motion from one shaft to another is called gear train. As I already said, to create large gear ratio, gears are connected together to form gear trains. They often consist of multiple gears in a gear train. The most common gear train is a gear pair connecting the parallel shaft. We can connect any shaft in any angle. The teeth of this type of gear, it may be helical, it may be spur, it may be bevel gear, any types of gear can be used. Angular velocity is a simple, the reverse of tooth ratio. Before going into the classification of gear trains, we need to understand important terminologies that we need to find, or parameters which need to be calculated in a gear train. First one in that is a velocity ratio. So velocity ratio is defined as the angular speed of a driver gear to angular speed of a driven gear. So whenever you have a gear train, we classify them as a driver gear and driven gear. Driver gear is the one which supplies the movement, and driven gear is the one which receives the movement. So usually the source is connected to the driver and the output will be from the driven gear. So if you take the ratio of speed of a driver gear to the speed of a driven gear, that is angular speed, we call it as a velocity ratio. So let omega 1 and omega 2 be the angular speed of driver gear uh, and driven gear respectively. So if we write according to the definition, so it will be denoted as VR. Usually velocity ratio is written as VR. So it is omega 1 by omega 2. So what is the formula to calculate omega 1? We already seen in the module 2, that is omega is equal to 2 pi n by 60, where n is a speed. So if you substitute in the place of omega, so 2 pi and 60 get cancelled, remaining is n1 by n2. So where it is nothing but omega 1 is omega in, which is the angular velocity of the input shaft, and omega out is the angular velocity of the output shaft. So this is the usual method we follow to calculate the velocity ratio. So velocity ratio can only be calculated when the gears are in mesh. Two gears in a mesh, we can calculate the velocity ratio. Second parameter is a train value. First one is velocity ratio. So train value, this is also related to the speed of driver and driven gear, but this is opposite of the velocity ratio. This is the reciprocal of the velocity ratio, or we also can tell that it is the ratio of angular velocity of the driven gear to angular velocity of the driver gear. So nothing but the reciprocal of the velocity ratio. 1 by velocity ratio, if you do, you will get the train value. So mathematically, if you write omega 1 and omega 2 will be the angular speed of driver gear and driven gear. The train value PV will be omega 2 by omega 1. Again substituting 2 pi n by 60. So remaining will be n2 by n1. So train velocity ratio is omega 1 by omega 2 or n1 by n2. This is omega 2 by omega 1 or n2 by n1. So when you analyze a gate train, as I already told, two parameters, velocity ratio and train value, which is very important. But when you write these relation, the ratios of driver gear and driven gear, we have to keep in mind the negative and positive uh, values. That is nothing but the direction or sense of rotation. So based on how the rotation takes place, we denote this in terms of positive and negative sign. So there are certain rules which has to be considered, which is already preset to be considered before writing these train value and velocity ratio. First one here is clockwise rotation is considered as positive and anti-clockwise is considered as negative. So if a gear is rotating in a clockwise direction with respect to the center, if you take one side clockwise, it is taken usually as positive, and anti-clockwise is taken as negative. This is with respect to individual gears. Okay, so when you consider the mesh of the gears, that is two gears in a mesh, so usually we write the positive and negative sign with respect to each gear. That means if one gear is rotating in opposite direction of the other gear, that is driver is rotating in opposite direction of driven gear, then that is usually denoted with a negative sign. Simple way of simple words, two gears if it is rotating in opposite direction, we denote with the negative sign, and if it is rotating in same direction, we call that as we sorry not call, we will denote it as the positive sign. So you can ask me when it will be rotating in same direction. So when it is an internal gear, you can see in this diagram here, one of the diagram, second one, we can see internal meshing takes place in a gear. So when there is internal meshing, usually the gears will rotate in the same direction. So in this case, we can write the value with a positive sign, and if it is external meshing, usually it will be denoted with the negative sign. So this is the direction of sense of rotation. So two main things, and clockwise it is positive, anti-clockwise it is negative, and if they are rotating in same direction, it is written as positive sign. If they are rotating in different direction, it is taken as negative sign. Moving to the next topic, that is types of gear train. So basically the gear trains are classified into four types. There is simple gear train, compound gear train, reverted gear train, epicyclic gear train. So we will be solving problems related to epicyclic gear train. So all these types of gear train we are going to study in detail. What is the train value, what is the velocity ratio, how to calculate that. Much more derivation will be there. So in exam they will usually ask you to explain these gear trains. Coming to the first type of gear train, that is simple gear train, the name itself says that the gear train which is very simple. So basic gear train which is defined as a shaft carrying one gear. There can be any number of shafts, and each shaft can carry any number of gears. But if it has to be called as a simple gear train, then each shaft should have one gear and they are in mesh. So you can see here this image. You can see there are different 1, 2, 3, 4, 5 shafts. Each shaft will be carrying one gear at a time. So each shaft they are in mesh. So this is how the simple gear train looks. So you can see all these images. So each shaft with one gear. So if this type of arrangement you see, then we call that as simple gear train. And one more second point is that the gears will be rotating with respect to the fixed shaft, fixed axis, fixed shaft, fixed axis. Here, so axis will be same. They don't change continuously. So this type of element, if you have, they call it as simple gear train. Some of the applications of simple gear train is that this is a type of gear train which is to connect gears when there is a large center distance is required. So when the shafts are have a large center distance, you can make use of the simple gear train. Second is to obtain the desired direction of motion of a driven gear, that is clockwise, counterclockwise. So if you want to change the direction from one direction to another, if you want to change from clockwise to counterclockwise, then you can make use of this simple gear train. Third is to get the high speed ratio. So if you want to get the high speed ratio, there is N1 and N2 what we saw in the previous two parameters. If you want to get higher ratio in that regard, if you can make use of simple gear train. So next is to find the velocity ratio of the simple gear train. This is a small derivation, very simple, which is used to calculate or which is used to find the velocity ratio. So this is the diagram which represents the simple gate train. You can see here there is a shaft A which is carrying gear 1, shaft B which is carrying gear 2, and shaft C which is carrying gear 3. So this is the side view and this is the front view diagram. So gear 1 we assume that it is rotating in clockwise, gear 2 it will rotate, obviously it will rotate in anti-clockwise, and next one the gear 3 that will rotate in the clockwise direction. So you can go on adding the number of gates, there is no restriction, but we are assuming 3 gates to calculate the velocity ratio. So let n1 n2 n3 be the speed of gear 1 gear 2 gear 3, and z1 z2 z3 be the number of teeth in gear 1 gear 2 gear 3 respectively. So each one will have n as the speed and z as the number of teeth. So first we will write the velocity ratio. So velocity ratio we need to assume a driver first. So we will assume the gear 1. So this gear 1 we will assume as the driver gear. So if you take the gear 1 as driver, so that will be driver for gear 2. So gear 2 will be the driver for gear 3. So combination of gears. There are 3 gears with 2 pairs. Gear 1, gear 2 is the first pair, gear 2, gear 3 is the second pair. So next when you write the velocity ratio, we have to assume each pair at a time. So first gear 1, gear 2 we have to assume. So what is the velocity ratio? We have already seen the definition. Velocity ratio is nothing but the ratio of angular speed of a driver gear to angular speed of driven gear. So here if you take in terms of speed, it is n1 by n2. So n1 by n2 is the speed. So if speed, so that can be equal to z2 by z1. So this will be the first equation. Similarly, we will write for the combination of gear 2 and gear 3. So that will be n2 by n3 because n2 is a driver for n in this combination. So n2 by n3. So that will be z3 by z1 because speed will be inversely proportional to the number of t usually. So this is how the relation is written. So you will have the equation 1, equation 2. So both are velocity ratio. So next we will multiply this equation 1 and equation 2, that is n1 by n2 into n2 by n3. So that will be z2 by z1 into z3 by z2. So here n2 n2 get cancelled and here z n2 to get cancelled. So remaining is n1 by n3. Here z2 will get cancelled. So here z2 will get cancelled. So remaining is z3 and z1. So next step we will get a velocity ratio, that is n1 by n3 which is equal to z3 by z1. So what do you understand by this? So if you see the expression here, we have n1 which is related to gear 1, n3 which is related to gear 3, and z3 related to gear 3 and z1 related to gear 1. So there is no expression related to the second gear, that is gear 2. We don't have any expression. So this indicates that velocity ratio is independent of the intermediate gears, or we also call this as ideal gears. There can be any number of ideal gears, but when you calculate the velocity ratio, it will be depending upon the first gear, that is a driver, and the last gear, driven gear. So n1, n3. If you have n4, suppose if you assume there is a fourth gear, then 2 and 3 will be the intermediate gears. So that will not be having any contribution towards the velocity ratio. So you will have an expression related to n1 and n4. Since here only 3 gears are there, second one will not contribute anything to the velocity ratio. So this is the first inference we draw from this expression. So this is the velocity ratio. So if you are writing the train value, so already we have seen train value nothing but the reciprocal of velocity ratio. So it can be written as opposite of the velocity ratio. So it is n3 by n1 equal to z1 by z3. This is about the velocity ratio and train value. Then regarding to the direction of rotation, second observation we can make is that with respect to the direction of rotation. So see here, the gear 1 was rotating in clockwise direction, gear 2 was in anti-clockwise, gear 3 was in clockwise. So if you just concentrate on first and last gear, they are in the same direction of rotation. Okay, so 1 and 3 are rotating in same direction, whereas the intermediate second gear is rotating in the opposite direction. I will introduce one more gear here, the fourth gear. So gear 4. What will be the direction? So clockwise, anti-clockwise, clockwise. So this will be again anti-clockwise. So the direction will be in the other direction. There is anti-clockwise direction. So what do you understand by this? So when I introduce the fourth gear here, this 2 and 3, this 2 and 3 will be the intermediate gears. So when I introduced two intermediate gears, first and last had opposite direction of rotation, whereas when I had only three gears, that means when I had only one intermediate gear, direction was same. So the conclusion we can make here is that when you have odd number of intermediate gears, the first and last gear will be rotating in same direction, and when you have even number of intermediate gears, the first and last gear will be rotating in opposite direction. So that depends on the idler gear. So if you have odd, you will have same direction. If you have even, you will have opposite direction. So this is the conclusion we can make with respect to the simple gear train. So second type of gear train, that is a compound gear train. So already we have seen the simple gear train. The second one here is slightly variation to the simple gear train. So there we had one shaft carrying one gear. So here each shaft carries two or more gears except the first and last. So there is an exception here. So there can be any number of shaft, any number of gears, but here each shaft will be can carry more than two gears, provided the first, this call it as a gear 1, and the last gear, the driven, the driver and the driven. So this shaft will be carrying only one gear, whereas the intermediate, there are so many gears connected in between. Here you can have any number of gears connected, placed in a single shaft. So if this type of arrangement we have, we call it as compound gear train. Okay, so we can see in this animation here, so driven and driver, they are having only one, and having only one gear in one shaft, whereas the intermediate will have more than one gear. The second is that all gears revolve in a fixed axis. Again, it is similar to the simple gear train. Here there is no change in the axis, all are fixed axis. So this is usually used to get the large velocity ratio in a limited space, usually in a gearbox or in the lathe speed gearbox. We make use of this compound gear train. So in a smaller space you can combine many gears so that you get a more or the higher value of the velocity ratio. N1, N2, N3 and 4 are the speed of the gear 1, 2, 3, 4 respectively. Same way Z1, Z2, Z3, Z4 will be the number of teeth in gear 1, 2, 3, 4. So consider gear 1 as a driver in the first case. So when you write the velocity ratio in the first combination 1 and 2, so 1 is a driver, 2 is a driven. So as velocity ratio says, it is speed of driver to speed of driven. So n1 by n2. So since it is inversely proportional to the teeth, so it will be z2 by z1. Second combination is between 3 and 4. There is no direct contact between 2 and 3. So when there is no direct meshing between the gears, you can't write the velocity ratio. So there is no velocity ratio for 2 and 3. Combination of 2 and 3. There is no combination at all. So you can't write the velocity ratio. So when you go for velocity ratio of 3 and 4, it will be n3 by n4. Since 3 is a driver for this combination, it will be n3 by n4, which is equal to z4 by z3. So we'll have equation 1 and 2. So multiply the equation 1 and 2. So n1 by n2 into n3 by n4 equal to z2 by z1 into z4 by z3. So there is no common term, so we can't cancel in this, sorry, we can't cancel in this number of teeth, but whereas here you can see n1 by n2 into n3 by n4. So n1 is like the speed of gear 1, N2 is the speed of gear 2 and N3 is the speed of gear 3, N4 is the speed of gear 4. You can see here, since 2 and 3 are in the same shaft, that is a gear B, the shaft B, you can tell that any number of gears on this shaft will have same speed. So this N2 and N3 will get cancelled because they are in the same shaft and their speed will remain the same. So whereas teeth may be different, teeth can vary, whereas speed can't vary in a shaft. So writing the final velocity ratio, that is N1 by N4, will be equal to N2 by N1, sorry, Z2 by Z1 into Z4 by Z3. So what do you understand by this? See here, velocity ratio N1 N4. So again, the same rule applies here. It will be from first gear and last gear. See in the other side, the number of teeth, Z2, Z4, 2 and 4th gear. What are these gears? As already said in the initial part, 2 and 4 are the driven gears for different combination. In 1 and 2 combination, 2 was a driven gear, and 3 and 4, 4 was a driven gear. So 2 and 4 both are driven gears, which is in the numerator. Whereas see the denominator, 1 and 3. 1 and 3 are the driver gears in the two combination. 1 was a driver in the first combination, 3 was a driver in the second combination. So you can see here in the numerator you will have only a driven number of teeth. In the denominator you will have a driver number of teeth. So you can write this as number of teeth in the driven gear to number of teeth in the product of number of teeth in the driven gear to the product of number of teeth in the driver gear. So when you write the train value, it will be reciprocal of the velocity ratio, that is N4 by N1 equal to Z1 Z3 by Z2 Z4, opposite of velocity ratio. So as already said, so this you can write as product of number of teeth in the driver gear and number of teeth in the driven gear. So train value, you can see here 1 and 3 are the driver gears and 2 and 4 are the driven gears. So this you can write in general. So this is about the velocity ratio and train value. Now coming to the some of the conclusion related to the compound gears, we can say that here everything depends on the intermediate shaft. In the simple gear train, it was related to intermediate gears, but here it will be intermediate shaft. So direction of rotation of first and last gear is same if we have odd number of intermediate shaft. So if you have odd number of shaft, you will have opposite direction of same direction of rotation. Whereas if you have even number of shafts, the intermediate shaft, you will have opposite direction of rotation. So this is the conclusion related to simple gear train. Coming to the next type, that is a reverted gear train, which is almost similar to the compound gear train. In other words, I can tell that it is the advanced version of compound gear train. So here the rule remains the same. The first and last gear will be in the same axis. Apart from the rule which we already learned in compound gear train, where first and last gear should the first and last shaft should be in having only one gear. Intermediate shafts can have any number of gears. So that rule remains the same. But here, added to that, if you place the first and last gear in the same axis, you can see in this diagram, there is a gear 1 and gear 4. They are in the same axis. So if you arrange in this manner, the first and last gear, it will be called as reverted gear train. So you can see the other gears 2, 3, they can be in any axis. There is no rule for them. But the first and last gear should be in the same axis. This is called as reverted gear train. So they are mainly used in the speed reducers, clocks, machine. So all gears revolve in fixed axis. There is no change in the fixed axis. The train value and velocity ratio will remain same as that of the compound gear train. There is no change. So derivation remains the same for both the cases. But here added to that we can write the relation with the center distance. So you can see if I take R1, R2, R3, R4 are the radius of each gear, that is 1 2 3 4 gears, I can write as r1 plus r2. You can see this distance r1 plus r2 is this distance. So this will be equal to the sum of r3 and r4. R3 and r4 distance is here, so this distance, so these two will remain same. Okay, so this relation we can write with respect to centered distance. That is the first relation. Second, we can write with respect to number of teeth, because number of teeth will always be proportional to the radius of the gear. If you have smaller gear, it will have less number of teeth. If you have larger gear, it will have more number of teeth. So they are usually proportional. So this R1 plus R2 equal to R3 plus R4 can be written in terms of number of teeth. That is, instead of R1, it is Z1, R2 Z2, R3 Z3, R4 Z4. So Z1 plus Z2 will be equal to Z3 plus Z4. Since number of teeth will be proportional to pitch circle radius. So this proportionality will holds good when only you have the gears with same module. So as I already told, the train value will be same as the compound gear train. So the formula will remain the same. This is the formula to calculate the train value if you want velocity ratio reciprocal of this. Next one is the planetary gear train. This is very important and very interesting. So we have problems related to planetary gear train. So coming to this, it is nothing but epicyclic gear train, one more name given to this, the planetary gear train. Why we call it as planet? Because the arrangement of gears are in such a way that there is a gear which acts as a reference, or we also call it as sun gear, and this is connected to other gear which is carrying the other gear with the help of an arm. Okay, so the planet gear which is rotating around the sun gear with the help of this arm. Okay, as we know, the planet rotates around the sun in a fixed axis. Similarly, there will be a gear will be rotating around the sun gear with the help which is supported with the arm. So this design can produce a large gear ratio in a smaller space. You can have any number of planet gears. Okay, there will be one reference sun gear, and the other gears will move around this sun gear. So this usually used to produce large gear ratio in small space, and used to get wide range of application in the marine gearboxes and electric screwdrivers. Okay, this is one advantage. Epicyclic means one gear revolving upon the around the other. The design involves planet and sun gears as one orbits the other, like planet around sun. As already said, there is a sun and planet arrangement. So one gear will be fixed and other will be rotating around it with the help of arc. So if this type of arrangement you have, we call that as epicyclic gear train, or it is also called planetary gear train. Why we make use of planetary gear? Because of the space requirement. So in the smaller space, you can combine many gears to achieve a larger velocity ratio. So position of input and output shaft is in a confined space. So this is one advantage. Better for achieving required velocity ratio. So whatever velocity ratio is required, it is easy to attain in the planetary gear train. Can have more than one input or output. So as I already told, one will be the fixed sun gear and other will be rotating around this. So you can have many number of such fixed gears, and the planetary gear train can rotate around this. So the output can be received from different points. So this is the advantage of planetary gear train. So we call this as power splitting mechanism. So you can see here power splitting mechanism by changing the input and output. Usually done in the automobile differential gears. You might have seen the in trucks and all, there are differential gears at the rear wheels. You can easily see that it is there in almost all the vehicles. So in that you can see very easily the differential gearbox, which is designed as a planetary gear train or epicyclic gear train. So next is to find the train value of this epicyclic gear train. So we had followed we followed a method to calculate train value and velocity ratio in simple gate train, compound gate train, and reverted gate train. Whereas in the train value of epicyclic gate train, we have two methods. First one is the algebraic method, and second one is tabular column method. Any method you can follow to calculate the train value. The answer will be remain the same. Only thing is that there is a variation in the methodology. One is algebraic, which makes use of just the formula to calculate the train value, whereas a tabular column method will just make use of three steps to calculate the train value. So first we will see the algebraic method. So assume a cyclic gear train, the gear 1, which is a fixed one, and a gear 2, which is connected or which is meshing with gear 1, and gear arm 3. You can see here third arm, which is supporting the gear 2 and connected to the center of gear 1. So consider gear 1, which is a sun wheel, and driver gear 2, which we call it as planetary gear, and the arm 3. So here, if you just write the train value of this combination, see this expression, it is minus z1 by z2. Train value, what do you mean by train value? It is the speed of driven gear to driver gear. So here, if you write in terms of number of teeth, it will be 1 by driver by driven. Number of teeth in the driver gear, the number of teeth in the driven gear. As I already said, speed and number of teeth are inversely proportional. So now there is one more thing, that is a negative sign. Why this negative sign has been put here? So as I already said, during the sense of rotation, the negative sign, we usually put this negative sign when two gears are rotating in opposite direction, correct? So when you write the combination of 1 and 2, first gear, this is rotating in clockwise direction. So when this is rotating clockwise, the second gear will rotate in anti-clockwise. So the direction of rotation is opposite here. That's why we put a negative sign. Negative sign indicates that 2 is rotating in an opposite direction with respect to gear 1. So we will write the speed of the wheel 1 relative to arm 3. So that is n13, 1 with respect to the arm 3. That is n1 minus n3, and speed of wheel 2 related to arm 3, n23. Speed of 2 with respect to 3, that is n2 minus n3. So writing the train value in terms of speed now. Train value in terms of speed, it is driven by driver. So driven here is second gear, so divided by first gear, n23 divided by n13. Speed of wheel 2 or gear 2 divided by speed of wheel 1. So we already written the relation, n23 is nothing but n2 minus n3, n13 is n1 minus n3. So this can be equated to the first relation. Here you have this train value, equate that to the relation of number of t. So this will be n2 minus n3 divided by n1 minus n3, which will be equal to minus z1 by z2. Okay, so this is how you equate and calculate the train value. It may be in terms of speed, or it may be in terms of number of teeth. So if I see in terms of speed, you can see here n2 minus n3 divided by n1 minus n3. So what is this? N1, n2. N2 is nothing but the last gear, and n1 is the first gear. So in general, if I want to write, it is NL, the last gear, minus the arm, speed of arm, divided by speed of first gear minus speed of arm. This is the general expression to calculate the train value. So whenever you want to calculate the train value with the algebraic method, you make use of this formula, NL minus NR divided by NF minus NR, where NL is the speed of last gear, F is the speed of first gear, arm, NR means the speed of arm. This is the algebraic method we follow to find the train value of epicyclic gate. Coming to the second method, there is a tabular column method. Same diagram we will consider. So first step here is draw a table of this form, which will contain serial number in the first column, condition of motion is a different condition we are giving to the arrangement. The subsequent columns will be the number of elements. So how many elements you have, that many columns will be there. So here you have arm 3, gear 1, gear 2. If you have any extra additional gears, add the columns here. So first step here is, there can be anything in the given question, so don't see the question now, so just assume different condition. First condition is that assume the gear, assume that the arm 3 is fixed. Okay, the 3 is fixed and you are giving one rotation to any one of the gears. When you fix the arm, other gears are free to rotate. So you are giving one rotation to gear 1. So whichever gear you give the first one plus one rotation, that will be the driver for entire arrangement. So here we are giving the fixedness to the arm 3, and gear 1 will have one rotation. Okay, so here that has to be filled. Here fix the gear arm and give plus one rotation to the gear 1. So in the subsequent column, what has to be filled? So here under the element you have to fill the speed values. So whatever you fill here, okay, so whatever you fill here in this area, okay, that will be the speed of the element. So arm 3 you are filling the speed value, gear 1 its speed value, gear 2 its speed value. Okay, so that has to be written in this particular area here. So now you are fixing the arm. So when you fix the arm, what will be the speed of arm? It will have the speed 0. So its speed is 0. And you are giving one rotation to the gear 1. So since you are giving one rotation to gear 1, what is the speed? It will have the speed of 1. So its speed is 1 RPM, revolution per minute. 1 is the speed. Okay. Now you are fixing the arm, it is 0. You are giving the rotation to gear 1. What will be the gear 2? It is also 1? No. Okay. So that it will have some value. So we have to calculate that speed. So how to calculate? By using the train value relation. Train value relation, you have n2 by n1. You can see here n2 by n1, it is equal to minus z1 by z2. So we need the speed value of gear 2. So bring this n1 to the other side. So it will be minus z1 by z2 into, what is the speed of gear 1 here? It is 1. So substitute that 1 here. So remaining is minus z1 by z2. This is the actual procedure to calculate the speed of gear 2. So in a simple way you can write this. How to write in a simple way? So now I want the speed of gear 2. So just write the ratio of number of teeth in the driver gear to number of teeth in the driven gear. Okay, so number of teeth in the driver here is gear 1, so it is z1 divided by z2. 1 is the driver, 2 is the driven. So number of teeth in the driver, number of teeth in the driven. So write this ratio. Next, see the direction of rotation. Is it same or opposite? So here, if you rotate the first gear in anti-clockwise, you will rotate in anti-clockwise direction. So direction is opposite. So put a negative sign. Okay. So easier way to write the ratio number of teeth in the driver gear to number of teeth in the driven gear. After writing the ratio, see the sense of rotation. So if it is rotating in same direction, positive. If it is in opposite direction, negative. Since here it is in opposite direction, put a negative sign. So it will be minus z1 by z2. Okay, this is the first step. Fix R, give one rotation to any one of the gate. Write the ratio of number of teeth in driver and driven with the negative, with the sense of rotation. So this is the first step. Second step, so whatever the speed values you wrote in the step 1, multiply x to that. That means you are increasing this revolution by x value. Okay, initially you had fixed arm, now you are increasing its speed by x. So if it is 0, when you multiply x, it will again be 0. The second step is multiplying x. So when you multiply x here, it will be 0 again. So 1 into x. So minus z1 by z2 into x. So this is the expression you are going to get. So that is the second step. Multiply x. Whatever expression you got, multiply x to that. That is the step 2. Third step. So you are increasing it to x. Now again you increase to add y to this. Okay. After increasing to x value, now add y. Okay, third step is adding some value y to this expression. So 0 plus y, you will get y, x plus y, that is y plus x. So y minus z1 minus z2 into x. This is the expression. So these are the three main steps. First, fixing the arm, give one rotation to any one of the gear, that is gear 1. Write the ratio of number of teeth for the other gear with the sense of rotation. Second step is multiply x to these expressions. Then last step is adding y to these expressions. So now here these three are our main three expressions. This what I have marked here. These are the three expressions. So here y is for arm 3, y plus x is for gear 1, y minus z1 by z2 into x is for gear 2. This is the speed values of that particular element. So seeing this expression, we can tell that Rm3 has a speed of y, gear 1 has a speed of y plus x, gear 2 has a speed of y minus z1 by z2 into x. So this is the expression we can write. Speed of arm is y, speed of gear 1 is y plus x, speed of gear 2 is y minus z1 by z2 into x. So this is the three main expressions which we are considering to calculate the train value. Okay, so how to calculate the train value we will see while solving the problems. We will see the first problem related to gear trains. That is, two spur gears A and B of an epicyclic gear train shown in the figure have 24 and 30 teeth respectively. The arm rotates at 100 rpm clockwise direction. Find the speed of gear B and on its own axis when gear A is fixed. Which instead of being fixed, the wheel A rotates at 200 rpm in counterclockwise direction. What will be the speed of gear B? So this is one figure given along with the question. So here are two gears A and B connected with the arm. Gear A has 24 teeth and gear B has 30 teeth, and arm has a speed of 100 rpm clockwise. So this direction is very important whenever you analyze a question. So there are two cases here. Find the speed of gear B. We have to find the speed of gear B when gear A is fixed. The first case, gear A is fixed. In second case, instead of it is fixed, it has 200 rpm counterclockwise direction. Again, you have to find the speed of gear. So two cases separately. In both the cases, you have to find the speed of gear B, whereas gear A speed will change once it is fixed. Second case, it is 200 counterclockwise per direction. So we'll solve this problem with both the methods, that is algebraic method as well as Taylor column. First with the algebraic method. So first step in algebraic method is we have to write the train value. Train value in terms of number of teeth. So it is train value number of teeth in driver gear, so number of teeth in the driven gear. So here they didn't mention anything in the question which is a driver gear, which is a driven gear. So in this case you can assume one gear as a driver and another one as driven. So you have to proceed in the same way throughout the problem. Okay, so here I will assume A as a driver gear and B as a driven gear. So when you write the train value, as I already told, it is number of teeth in the driver gear A to number of teeth in the driven gear B. So A ZA by ZB. So here when you give clockwise rotation to gear A, gear B will rotate in anti-clockwise direction. So I will put a negative sign. Substitute the value. There are 24 teeth in A and 30 teeth in B. So don't solve this, leave it as it is. We have to equate it later. So let the fraction be as it is. So give this as equation 1 with a negative sign, minus 24 by that. Next, apply the formula. What is the formula? It is NL minus NR divided by NF minus NR. So that is the formula of the train value for epicyclic gear train. So use that formula now. Train value is NL, NR, NF, NR in terms of this. Substitute the values here. Which is the last gear? NL means the speed of last gear. So when you take A as a driver, it will be the first gear. So obviously B will be the driven, so that will be the last gear. So here NL means you have to substitute the value, that is the speed of NB. NB minus NR, speed of B minus speed of arm. Speed of B is unknown here, speed of arm is given in the question. Next, in the denominator, NF, first gear, that is NA minus NR. Okay, so I have substituted according to this problem. So the formula is here. So here it is substituted in terms of the given problem, that is NB minus NR divided by NA minus NR. So this is the equation 2. So in that equation 1, equation 2, we will equate that. So minus 24 by 30 and the given NB minus NR divided by NA minus NR. So we will solve the cases one by one. Case 1. What is the case 1? We have to find the speed of B when speed of, that is the arm gear A is fixed. So substitute the values. So 24 by 30, leave it as it is. NB is unknown. NR, what is the speed of arm? Arm speed we have already written there, so it is 100 given clockwise, so it is positive here. So NB minus 100 divided by NA is 0 here, again this arm. So solve this, we will get the answer for NB as 180 rpm. If you get the positive sign here in the answer, write clockwise in the bracket. If you get negative sign, write counterclockwise. That is the case 1. Next, case 2. What is case 2? Again, you have to find speed of B when NA has 200 rpm counterclockwise direction. So you have to be careful when substitute this counterclockwise. So whenever counterclockwise is there, we have to substitute with the negative sign. So take again the same relation, minus 24 by 30 equal to NB, we have to calculate minus 100. So in place of NA, since it is counterclockwise, you have to substitute minus 200 minus 100. Solve this, you will get the value for speed of VAB, that is 340 rpm. Again it is positive, so we will get it is clockwise direction. So this is the solution we do with the algebraic method. So next we will see the same problem, how to solve with the tabular column method. So as I already said, we have to create a table of this manner. So condition of motion, all the elements, there is the arm, gear A, gear B. So first step, as we already discussed in theory part, first step, fix the arm, give one rotation to one of the gear. That is, I will fix the arm and give one rotation to gear A. Okay, so when you fix the arm, its speed will be 0, and you are giving rotation to A, so its speed will be 1. So here, what you are filling under this table, this area here, it is always the speed value. If it is fixed 0, it is 1 rotation, enter here 1. So first step is fixing the arm and give plus 1 rotation to gear A. You can give the rotation to gear B also, nothing wrong in that. So the expressions will change, that's it. There is no change, there will not be any change in the answer, only the expressions will change. Okay, so fix the arm and give one rotation to gear A. So since you are giving rotation to gear A, that will be your driver now. Okay, so for the arrangement, gear A will be the driver. So what is the speed for gear B? So it is already set in theory part. So we have to write the ratio of number of teeth in the driver to number of teeth in the driven gear. So here driver is A, driven is B. So it is ZA divided by ZB. Okay, so after writing the ratio, we have to see the sense of rotation. Okay, so sense of rotation, both are rotating in opposite direction, so put a negative sign. So number of teeth in the driver gear, so number of teeth in the driven gear with the negative sign because they are rotating in the opposite direction. So this is the main step. So if you are able to write this first step properly, then subsequent steps are similar, there is no change. Okay, so arm is fixed, so it is 0. You are giving one rotation to gear A, so plus 1. Then gear B, so method of writing here is
ZA by ZB, that is the number of teeth in the driver to number of teeth in the driven. After writing the ratio, see the sense of rotation. If these two gears, that means A and B, if we are rotating in the same direction, we have to put positive. If they are in opposite direction, put negative. Since here it's opposite, this negative sign. Second step is multiplying x to this previous step. So 0 into x is 0, 1 into x, x. So multiplying x to the previous expression. Third step is add y to the all these three cases. So y plus x in the second. So here 0. If you add y, is y. X plus y. Then here if you add y, is y minus za by zb into x. So this three expressions what you get here, it is the speed of the respective elements. Y is the speed of arm, y plus x is the speed of gear A, y minus za by zb into x is the speed of gear B. So the requirement of the problem is we have to find the speed of gear B. Okay, so speed of gear B means we have to solve this expression. So if you find, or if you find the answer for this expression, that is nothing but speed of gear B. So here whatever unknowns we have, first we have to find those. What is y, what is za, what is zb, what is x, we have to calculate. Okay, so if you able to find all these unknowns, we can find the speed for gear B. Okay, now what is y here? Y is nothing but speed of arm. Okay, speed of arm, if you calculate, if you know, we can directly substitute. Za is number of teeth, zb is number of teeth of B, is A, is B. So x we have to find. We'll see how to find this. Okay, so next step is solving these three expressions. So as I already said, speed of arm y, speed of gear A, y plus x, speed of gear B, y minus za by zb into x, what we received from the table. So going to the case 1. Case 1, where gear A is fixed, we have to calculate the speed of gear B. Okay, so first we will see, since gear A is fixed, okay, in the given case they are telling that gear A is fixed, that means gear A will have a speed of 0. Okay, according to the table we got y plus x is the speed of gear A. Okay, but in the question they are telling it is fixed. So equate those two cases, what you got from the table and what is given in the question. Okay, y plus x is the expression what you got from the table. Okay, in the question it is telling it is fixed here. So what you have to do is y plus x equal to 0, since it is fixed. Solve this expression. Okay, what is the value of y? What is the speed of arm? That is given 100. Okay, so y is equal to 100. Y is 100 now. Substitute that 100, you will get the value of x. X is minus 100 here. So you got the value for x. Now coming to the speed of gear B, we know the value of y, we know this value of za, zb we know, x we calculated just now. So we can solve this expression to find the speed of gear B. So gear B is y minus za by zb into x. Substitute all the values. 100, 24, 30, minus 100 is x. To solve this, so whatever answer you get, it is the speed of gear B for the case 1. Okay, so if you compare this with the answer you got in the algebraic method, it will be same. Okay, so this is for the case 1. Now coming to the case 2. So in the case 2, he is telling that we have to find the speed of gear B when we have gear A rotating at 200 rpm counterclockwise. So it is minus 200. Same method. So there we had equated that to 0 since it was fixed. Now equate that y plus x to minus 200. Okay, so minus 200 and substitute all the values. So y is 100, x we have to calculate equal to minus 200. So x you will get as minus 300. Next substitute for the expression of gear B, y minus za by zb, same expression. Here the only the value will change. Y will remain 100 as it is, za as it is, the number of teeth, zb as it is, x is minus 300. Only that is a change compared to the previous case. Solve this. So answer what you are going to get, that is the expression for, sorry, the answer we are going to get, that is the speed of gear B in the case 2. So if you compare this, it will be equal to the answer you got in the algebraic method, second case of algebraic method. This is a solution for first problem. We'll move to the second problem. That is, in a planetary gear train shown in the figure, the sun gear B is fixed. Find the speed of gear B if the arm A rotates at 60 rpm counterclockwise direction. The number of teeth on B, C, D are 120, 60, 40 respectively. Okay, there are three gears B, C, D. All three are connected with the arm A. So in this problem, the figure is given. So there are problems where they won't give the diagram. So we have to analyze the question and draw the diagram that will solve later. But in this problem, he has given the diagram. First, we will write the given data. What are the given data? Teeth B, C, D is given 120, 60, 40. So he is telling that sun gear B is fixed. Okay, so its speed is 0. Okay. Next, he is telling arm A rotates at 60 rpm counterclockwise. The speed of NA is minus 60. So counterclockwise, so it is minus 60. So what you have to find? We have to calculate the or find the speed of gear D. So ND we have to calculate. First we will see with the algebraic method. Same method, first you have to write the train value. Clear? So when you write the train value, take driver and driven combination, number of teeth on driver to number of teeth on driven. So all the driver gears you have to consider. Clear? First combination. BC is the first combination, CD is the second combination. So we'll write the train value for first combination. Okay, ZB is a driver here, ZC is a driven. So it is ZB divided by ZC, number of teeth in the driver to number of teeth in the driven in this first combination. Clear? So in this B and C, what is the direction of rotation? Suppose B is rotating in anti-clockwise, C will be in anti-clockwise, clockwise. So they are opposite direction. So put a negative sign for this. So ZB by ZA, sorry, ZB by ZC with the negative sign. This is for the first combination. Multiply that to the second combination, the ratio of second combination. That is combination of C and D. So in C and D, C is your driver gear, D is the driven gear. So it will be ZC divided by ZD. So this is written here, ZC divided by ZD. Okay. Now if you analyze these two gears with the sense of rotation, if you give clockwise rotation to C, D will rotate in the anti-clockwise direction. Okay, they are external machine, so they will have opposite direction of rotation. So put a negative sign. Okay, so each combination you have to take at once. A BC at once, CD at once. Write the train value in each case. Multiply those two relation. Now cancel the common terms. Cancel the common terms, that is ZC get cancelled, ZC get cancelled. So negative negative will become positive. Remaining is ZB by ZD. Substitute the number of T. ZB and ZD are given in the problem. So 120 by 40. That will be the first relation of train value. Next, use the formula. That is NL minus NR divided by NF minus NR. Substitute the values here. So here, no need of taking each combination at once. So just see first and last gear. So if I take gear B as first gear, D will be the last gear. Okay. So here, instead of NL, you have to substitute ND, and instead of NF, it is NB, and instead of N arm, it will be NA. Okay. So whatever the relation you have for NA, substitute that. So here this is expression 2. Equate the 1 and equating 1 and 2, you will get 120 by 40 and substitute the values. Okay, arm speed is counterclockwise in 60 minus 60. B is fixed. So solve this, you will get the value of gear D speed is 120 rpm. So this is how you solve with the algebraic method. Coming to the tabular column method, the same arrangement we have to solve with the tabular column. So this is how the tabular column has to be prepared. So first serial number, condition of motion, then list out all the elements, that is arm A is there, B, C, D gears. Okay, so first here same method, fix the arm, that is A will be fixed here, give one rotation to gear B. Usually we give the rotation to first gear. Okay, if you have compound gear you have to give rotation to that. Here it is just a simple gears, so give one rotation to B. So fix the arm and give one rotation to gear B. So since you are fixing the arm, its speed will be 0 here, and you are giving one rotation to gear B, so it will have rotation of 1. Next, coming to C, so you are giving rotation to B, so B will be the driver here. Okay, B is a driver gear. So coming to gear C, C which is the driver, so B is a driver, so number of teeth in the driver gear to number of teeth in the driven gear. So write that relation first, ratio of number of teeth in the driver to number of teeth in the driven, then see the sense of rotation. So if you see B and C, they will always rotate in the opposite direction, so put a negative sign, so it is minus ZB by ZC. Next, for gear D, so gear D, which is a driver for gear D? C is a driver for D. But what is a driver for C? B. So you have to start from first, where you gave the plus 1 rotation. This rotation where you give to which gear, from there you have to start. Clear? B is a driver for C, C to D. So the transfer of movement takes first from B, then to C, then to D. So all the relation has to be taken into consideration. Clear? So first write the relation of B and C, because it started from here, BC. So it is ZB by ZC with a negative sign because they are in opposite direction. Number of teeth in the driver to number of teeth in the driven. Next, second multiplied by ZC into ZD, number of teeth in the driver. For this combination, C is a driver and D is a driven. So ZC by ZD with a negative sign indicating that they are in the opposite direction. So here ZC get cancelled. Negative negative becomes positive. So remaining is ZB by ZC. So next step, multiply the X. So when you multiply X, 0 into X is 0, 1 into X is X, minus ZB by ZC into X, and here after cancelling the common terms, remaining is ZB by ZD into X. So this is the second step. Third step, add Y to this. Adding Y, so 0 plus Y is Y, X plus Y is Y plus X. So to this expression, Y minus ZB by ZC into X, and same Y plus ZB by ZT into X. So this is the expression for speed of these particular elements. Y has a speed is the speed of arm, Y plus X is the speed of gear B, Y minus ZB by ZC into X is the speed of gear C, and the last expression is the gear D. So in the problem they have asked to find the speed of gear D. Whichever element they ask, you have to solve that particular expression. That means we have to solve this expression now. Okay, Y plus ZB by ZT into X. This expression, if you solve and find the answer, that will be the speed of gear D. Okay, so we will start solving that. So these are the speed, as already said. So first I need to solve this speed of arm. Y is nothing but speed of arm, that is given in the problem. Substitute that. Okay, and B is said to be constant. So if they set constant, this expression has to be equated to 0. Y plus X is 0. Arm speed is given 60 counterclockwise, so minus 60. Solve that, we'll get the value for X. X is 60. Okay, now speed of gear D. Y value is known 60. This is 60. ZB is given in the problem, ZD is given in the problem, X we just calculated here. Substitute all those values. Okay, so you'll get the answer for speed of gear D. So compare this with the algebraic method, we will get the same answer. So this is the solution for second problem.
Coming to the next problem, that is in a reverted epicyclic gear train, the arm A carries two gears B and C and a compound gear DE. The gear B meshes with gear E and gear C meshes with gear D. The number of teeth on gear B, C, D are 75, 30 and 90 respectively. Find the speed and direction of gear C when gear B is fixed and arm A makes 100 rpm clockwise. So this is another type of problem where diagram is not given in the question. Okay, so seeing the question itself, you have to analyze the given statement and you have to draw the diagram. So see here, first term, that is reverted epicyclic gate train. So what do you mean by reverted? Reverted, as we saw in the classification, the first and last gear, the first gear, the driver, and last driven gear should be in the same axis. So that is reverted. So that condition has to be satisfied. Then epicyclic. So there must be an arm supporting the gear and one gear should be reference. So arm A is given here, carries two gears. So two gears are connected with the arm. Okay. So now this arrangement is supported by a compound gear. So this combination is of reverted gear, epicyclic gear train, and compound gear train. So what do you mean by compound gear train? In one gear you have one shaft, you have two gears. Okay, D and E are those two gears here. Clear? So you have to place the gears in such a way that D and E comes in same shaft. And next condition, the so see here, the statement gear B meshes with gear E and gear C meshes with D. Okay, meshing takes place between B, E is one combination, C, D is second combination. So the care has to be taken while drawing the diagram. So DE in same shaft, BC should be in mesh, and B and C should be in same axis. Okay, so the arrangement somewhat looks like this. Okay, you can see here the condition is satisfied. It is a reverted gear train, so B and C are in the same axis. Okay, and DE, the compound gear, they are in the same axis. So there is a arm A which supports B and C, and the B is meshing with E, C is meshing with D. Okay, so as per the given condition, we have drawn the arrangement. So once you draw this figure, then you can go for the tabular column method. Okay, any method you can follow, algebraic or tabular. So we'll solve with the tabular column method here. So number of teeth on gear B, C, D are given and arm A speed is given. Clear? So first prepare. So the table consists of condition of motion and the subsequent columns will be containing the elements. So arm A, compound gear DE, gear B, gear C. So observe here, gear D and E is written in single column because whatever you fill here, as I already told, the speed value. So DE, since they are in the same shaft, their speed will remain same. So whenever you have a compound gear, write that in the individual column. So start the steps. So first step is giving one rotation to the gear and fixing the arm. So fix the arm and give one rotation to any one of the gear. Okay, so in the previous problems we had seen, we were giving rotation to initial gear or the first gear. So whenever you have a compound gear, it is advisable to give that one rotation to compound gear because uh, this will simplify your equation. What you're going to get at the end, that will get simplified if you give the one rotation to compound gear DE. So always whenever we have a compound gear, give that plus one rotation to this compound gear. So this will be 0, since you're fixing the arm, and this rotation you have to give it to compound gear. So when you give that rotation to compound gear, this will act as a driver. Okay, so the subsequent gears what you are going to uh, write the speed value, so this will be the driver. Okay, so whenever you remember, you can make a note, whenever you have a compound gear, give the one rotation to that compound gear, which will simplify
your equations. Okay, so first step, fix the arm and give +1 rotation to gear DE. So you can see here arm A is 0 speed, compound gear DE is +1. So here gear B. Now gear B is meshing with which gear? Okay, so this is, as I already told, this is our driver. This gear is the driver gear, so this will be the driver gear. So out of this D and E, which is in mesh with gear B? So as given in the question, E is in mesh with gear B. Okay, so E is the driver and B is the driven gear here. So when you write the ratio here, it is number of teeth in the driver gear to number of teeth in the driven gear. So you are giving one rotation to gear E, so this will be the driver. So ZE divided by ZB. So they are in mesh, so you have to write the ratio in this manner. Next, see the sense of rotation. So if you give clockwise rotation to gear E, B will rotate in anti-clockwise. So this ratio has to be written with the negative sign. Okay, so gear B speed value is number of teeth in the driver gear, number of teeth in the driven gear. Since you are giving one rotation to compound gear DE, E will be the driver for gear B here. So this is how you write for gear B. Next, coming to gear C. Now gear C is in mesh with which gear? You can see the diagram. C is in mesh with the D. Okay, so D, whatever the rotation you are giving to D, that will be transferred to C here. So D is the driver for gear C. So number of teeth in the driver. Okay, D is the driver here, number of teeth in the driver gear to the driven gear. C is the driver, so ZD by ZC. Now again, sense of rotation, if you give clockwise to D, C will rotate in the anti-clockwise direction, so a negative sign. Okay, so arm A is fixed, so 0. Compound gear, you are giving the rotation +1. Gear B, it will be driver, number of teeth in the driver gear to driven gear. So gear C again the same with the sense of rotation. We'll consider the sense of rotation. Next step, the second and third steps are same how we did in the previous problems. Okay, multiply x to the previous case. So 0 into x is 0, 1 into x is x. This minus ZE by ZB multiplied by x. So this is the minus ZD by ZC into x. Third step, add y to these cases. So 0 plus y, x plus y here. Next here y minus ZD by ZB into x, y minus ZD by ZC into x. So this, the third column, what you are going to get here, these four are the speed equations of these particular element respectively. So arm A has the speed of y, compound gear has y plus x, gear B has this y minus ZD by ZB into x, y minus ZD by ZC into x is the speed of gear C. Okay, so this is for each element. Okay, these are the speed equations of all the element arm y, compound gear y plus x, and speed B, speed C. So what is asked in the question, we have to solve that equation first. Okay, so in the question he has told that gear B is fixed. Okay, so whenever a element is fixed, its speed remains 0. Okay, so in the question it is told it is fixed, and the equation what you got from the tabular column is this one. Okay, so equate this equation to 0. Since we are told it is fixed, you have to equate this speed equation to 0. Okay, then solve this. Okay, now to solve this, y value is given in the question, but uh, zb is given in the question, ze is unknown. Okay, so we have a reverted gear train relation we have seen when studying the classification. Okay, so if you see the arrangement, I can write rd minus re equal to rb minus rc. If you see the arrangement, so since r, the radius, is proportional to the number of teeth, since they have same pitch, so this proportionality condition holds very good in this case. So RD minus RE equal to RB minus RC relation can be written as ZD minus ZE equal to ZB minus ZC. So substitute all the known values. So D is given in the problem, E is unknown, B is given, C is given. So you'll get the number of teeth in gear E. So there is 45. Substitute that in this particular equation. So y is known 100 given in the question clockwise. 45, what you got here answer, 75 is given in the question. X you have to calculate here. So x you will get as 166.66. Don't write any unit because it is just a number. Okay, no unit for this. So this is the x value. So now what is asked in the question is to calculate the speed of gear C. So gear C means you have to solve this particular equation which you received for gear C from the table. Okay, now if they ask speed of gear D and E, you have to solve this equation. Now they have asked for the speed of gear C, so solve this equation, y minus zd by zc into x. Okay, so take this equation, substitute all the known values. So y is given in the question, zd is given, zc is given, x you just calculated now. So substitute all those values. So the answer 600 rpm, what you get is a speed of gear C. Okay, so substitute and direct answer you will get. So this is the solution. So next problem, in epicyclic gear train, the internal wheel A and B, the compound wheel B and C rotate independently about the axis. The wheel E and F rotate on pins fixed to the arm G. E gears with A and C and F meshes with B and D. All wheel has the same pitch and number of teeth in C, D, E, F is given. Sketch the arrangement. Find the number of teeth on A and B. If the arm G makes 150 rpm clockwise and wheel A is fixed, find the speed of B. That is one condition. Second condition, if arm G makes 150 rpm clockwise and wheel A makes 15 rpm counterclockwise, find the speed of B. Okay, so two cases where you have to calculate the speed of wave B. So here again the figure is not given in the question, but the description is given. So based on the description, we have to draw the arrangement. So that is what asked in the question. Sketch the arrangement is asked in the question itself. Okay. So see here, in the epicyclic gear train, the internal wheel AB. What do you mean by internal wheel? So see here the term internal wheel. Internal means the teeth are inside. It's not external teeth. There is an internal teeth. So there are two gears A and B which is having internal teeth. So it is understood that whatever the remaining gears are there, that should be inside this gear. So these two gears are very big gears. Okay. Next, the compound wheel DC. What is mean by compound wheel? So instead of gear, they can tell that as wheel also. Same thing. Here, so it is compound gear or compound wheel DC. So this should be in same shaft. Rotate independently about the axis O. So the statement says that there is an internal wheel, there is a compound wheel. So these four gears A, B, C, D. These are the four gears which is connected to a same axis, which is having the same axis of O. So four gears has to be placed in same axis. Next statement. Wheel E and F rotate on pins fixed to arm G. Okay, arm G means there should be center. Okay, that is also in the same. Whatever center is given, the arm G is fixed to the same center, which is supporting E and F. Yeah. Next, E gears with A and C, F meshes with B and D. So the meshing, E meshes with these two gears, F meshes with B and D. Okay, so it is understood that C, A and B are outside, C and D are inside. So in between these two gears, E and F should be there. So all the wheels have same pitch and number of teeth are here. So till here, so this till here, whatever the description is given, that is the description of the arrangement of the gears here. So seeing this, so if you draw the arrangement, it looks somewhat like this. So see here, everything is satisfied. A and B are the internal wheels. So it is the largest wheel. You can see here, the center is O with compound gear DC here. C and D are here at the center. E and F are meshing with two gears, that is E meshes with A and C, and B meshes with F meshes with B and D.
So after drawing the arrangement, second thing asked in the question is to find the number of teeth on A and B. Okay, so to find the number of teeth, see the statement given in the question, gears have same pitch. That means pitch circle radius is proportional to number of teeth. R proportional to Z. Okay, so first relation for RA. RA means this distance from here to here, radius of R from center. This is RA. Okay, so see how you can write this relation. So if I write this RA distance, RC is one distance, radius of gear C plus 2 times the radius of RE. So this gear and C, radius of C gear and 2 times the radius of gear E will give you the radius RE. So that is what written here. RA can be written as RC plus 2 times RE. So since R is proportional to Z, instead of R you can write Z. ZA is equal to ZC plus 2 times of ZE. Substitute the given data. ZC is given in the question, ZE, that is the number of teeth in C is given, number of teeth in E is given. Substitute, you will get the answer for ZA. Similarly, if I write for RB, RB is nothing but distance from this point to this point. Okay, this is RB. Okay, so this here RD plus 2 times of RF. Okay, so that relation is written here, 2 times RF. So since proportionality relation is there, ZB is equal to ZD plus 2 times of ZF. Substitute the given data, the answer is 62 teeth. So A is having 64 teeth and B is having 62 teeth. Okay, this is how you have to calculate the number of teeth. So next thing is asked to find the speed. So to find the speed, we'll make use of tabular column method. Okay, so this is how you have to prepare the table. So condition of motion, arm G is written, compound gear. So as I told in the previous problem, whenever you have compound gear, that has to be written in single column, then gear F, gear B, gear E, gear A. Okay, all the gears are considered here. We didn't leave any element. You can, if you cross verify all elements, even the arm is considered. Okay, so first step here, fixing the arm and giving rotation to any one of the gear. Okay, any gear you can give out of this 1 2 3 4 5 6 7 gears, 6 gears we can give rotation to any gear. But I told in the previous problem, whenever you have compound gear, give rotation to that compound gear. Okay, that will simplify the problem. So fix the arm and give one rotation to gear D and C. Okay, compound gear DC. Give the rotation to that gear. So since you are fixing the arm speed is 0 and rotation you are giving to DC, so its rotation will be 1. What about F? Okay, so say you are giving rotation to compound gear DC, so that is your driver now. Clear? So when you write for F, see from where this gets the movement. C is in mesh, F is in mesh with which gear? D. Okay, you can see here D gear is there, F is in mesh with the D. So D is the driver for gear F. Okay, so when you write the relation here, it will be number of teeth in the driver gear to number of teeth in the driven gear. Okay, driver gear here is D and driven gear is F. Okay, so it is a ZD divided by ZF. Here ZD is divided by
ZF, see the sense of rotation. Okay, there is a opposite direction. If you give clockwise rotation to gear D, F will rotate in the anti-clockwise direction, so there should be a negative sign. So it is minus ZD by ZF. Okay, so next, coming to gear B, see that where does the movement starts. So B gets the movement due to gear F, F gets the movement due to D. So there are three gears. From D it starts, a transfer to F, F to B. So all has to be considered, all the combination has to be considered. So first we will write for ZD and ZF, that is a combination of F and D. So ZD is the driver here and transfer to F. So it is ZD by ZF with a negative sign. Okay, so since they are rotating in the opposite direction, negative sign. Next pairs are F and B. Okay, from D it is transferred to F, F it is transferred to B. So FB is second combination in this particular arrangement. So here, which is a driver? F is a driver for B, so it has to be written in the numerator. So ZF divided by ZB, ZF divided by ZB. So that is what written here. What about the direction of rotation? If F rotating in clockwise, B also will rotate in the clockwise direction, so the sign is positive. So it is minus ZF by ZF, ZD by ZF into ZF by ZB. So there can be any number of gear. You have to write the train value for all these combination. First DF, then FB, then multiply this. So F get cancelled here, remaining is minus ZD by ZF. Okay, so this is for gear B. Coming to gear E, so gear E is here, which is the source of movement for gear E. So this gear E is in mesh with gear C. Okay, C is our source. Since you are giving one rotation to DC, C is also a source. So C will be the driver for gear E. So it is ZC divided by ZE with a negative sign because the direction of rotation is opposite. Okay, last one, gear A. Gear A, gear A is in mesh with E, E is in mesh with C. So the movement starts from C, then it is transferred to E, then it is transferred to A. Okay, so here your three gears are there, two pairs. So each pair has to be taken at a time. First we will take for C and E. Okay, so it is minus ZC by ZE, first combination, then into E is a driver for A, so it is ZE by ZA. So they are rotating in same direction, so it is positive. So EE get cancelled, remaining is minus ZC by ZE. So this is how the equations are obtained in the first step. Second step, multiply x to this. So whatever you obtained in the first step, so multiplying x into 0 0, x into 1 1. So multiplying zf by zd by zf into x, minus zb by zd by zb into x, minus zc by zd into x, minus zc by zd into x. So multiplying x to all these cases. Third step, adding y. So add y to all these expressions. So the final table, last line what you get, these are the speed values of these particular elements. So whichever is asked in the question, solve that equation. So in this problem, he has asked to find the speed of gear B. So solve this equation. So if you solve this equation, you will get the speed of gear B. We will do that in the next step. Okay. Okay. So first, he has asked to calculate the B when arm G makes 150 rpm clockwise and wheel A is fixed. Okay. So what was the speed of G? It is y according to the table. So y is 150, and since A is fixed, its equation has to be equated to 0. Whatever the equation you obtained from the tabular column, equate that to the 0, wheel A. Okay. So when you substitute the values, 150 minus ZC is given in the problem, ZA is what you calculated, X you will get 342.86. Then consider the gear B equation, whatever is circled in the previous slide. Okay, so take that equation, substitute all the given values. Okay, y, substitute z is given in the question, zb you have calculated, x you just calculated now, substitute that, it is 6.22. If you get the positive answer here, it is clockwise, if it is negative, counterclockwise. Okay, so it is 6.22 rpm clockwise for the first case. Next, second case, it is find the speed of gear B when A makes 15 rpm counterclockwise and G makes 150 rpm clockwise. So see this, it is counterclockwise here and G is clockwise. So the steps are same, but see here Y 150, that is same. But in the previous case it was A was fixed here, but here A is making 15 rpm counterclockwise. So here you are equated to 0, but here it has to be equated to minus 15, minus because you have counterclockwise movement. So the equation has to be equated to minus 15. Solve the equation, you will get the value for x, 377.14. Then consider the equation of gear B, substitute all the given values. Same in the previous, how you did in the previous case, you will get the answer minus 8.6, 8.16. Since you got a minus sign, the answer has to be written as 8.16 rpm counterclockwise. Okay, since negative sign you got. So this is how the problem is solved. Next topic is torque in epicyclic geometry. So till now we have solved the problems to calculate the speed, the train value, velocity ratios. So we can also calculate the torque in a gear train. Okay, so there are some certain set of rules or equations which is considered in an equilibrium condition to calculate the torque in any epicyclic gear train. So whenever you find the torque, three things are mainly considered. They are, one is the input torque, second is the output torque, and the holding or the fixing torque. So we are taking it as T1, T2, T3. So in the entire arrangement of gear train, these three are very important. Intermediate torques we are not considering here. Only the first torque, the final torque, and the fixing torques. Okay, whatever is supporting those gears, that is considered here. So T1, T2, T3. So whenever in the equilibrium condition, these three torques, sum of these three torques should be equal to 0, and it will always be equal to 0. Okay, if it is properly designed, the torque, the input torque or the driving member torque, output torque, driven member torque, and the holding torque. These, if you add these three torques, will be equal to 0. Now, what is the torque? Force into distance. So it is, if I write T1 as F1 and R1, T2 is F2 R2, T3 is F3 R3. So adding that will give 0. So where F1, F2, F3 are externally applied forces to for the moment or the force you are applying at a distance, or the force applied at radius of r1, r2, r3. So torque can be written in terms of force and radius. So if friction is neglected here, so net energy is dissipated, the gear train must be equal to 0. Okay, so if the friction is neglected, it is T1 omega 1 plus T2 omega 2 plus T3 omega 3 equal to 0, where omega 1, omega 2, omega 3 is the uniform angular velocity of driver driven and fixed member. Okay, these relations are very important. This first relation, second, third. Okay, these three are very important to find the torque in any member. So if friction is neglected, we will have uniform angular velocities. So we will solve one problem, how to calculate torque in a specific way. So first problem in that, an epicyclic gear train of sun and planet type is shown in the figure. So the diagram is given in the problem. The pitch diameter is internally toothed ring D is approximately 228 mm and the module is 4 mm. When the ring is stationary, the spider A, which is 3-planet wheel C of equal size, is to make one revolution for every 5 revolution of the spindle carrying the sun wheel B. Determine suitable number of teeth for all the wheels and exact pitch circle diameter of ring D. If a torque of 30 Newton meter is applied to the sun wheel B, what will be the torque required to keep the ring stationary. So see the problem. An epicyclic gate train of sun and planet type. So this is another term used for epicyclic gate train. So as I told in the description, the classification, it is sun and planet type. The pitch diameter of internally toothed D is approximately 228. See here the term approximately. It is not the exact here. So approximately 228 mm and the module is 4 mm. Okay. When the ring is stationary, ring means the external D is fixed. The spider A, which carries the three planets, that is another term. The spider is another term used for arm. Instead of arm, they can call it a spider. The three, if the connection is like this, they call it as a spider, which carries three planet wheels C of equal size. Okay, there are C. Three gears are there. C, C, C. They are planet wheel of same size, which make one revolution for every 5 revolution of the spindle carrying the sun will be. B is at the center. So see the statement. So this is required to solve later. So C makes one revolution for every 5 revolution of the gear B. That is the meaning of this statement. Here. Now determine the suitable number of teeth for all the wheels and exact pitch circle diameter. Here it is in the question they are given approximate. So we have to calculate the exact pitch circle diameter of gear D. Okay. If torque, second part of question, if a torque of 30 Newton meter is applied to the sun wheel B, what will be the torque required to keep the ring stationary? Okay. So we have to find the torque here also. If the ring station, nothing but stationary means equilibrium condition. Here. So first try the given data. Teeth is given, torque is given, TB 30 Newton meter, approximate DD is given, that is approximate pitch diameter of ring D is given, module is given M 4 mm. Okay, so this is the meaning of the question. So we'll start solving this. So first, since the statement is given in the problem that all gears have same pitch, the pitch circle radius is proportional to number of teeth. Okay, whenever they have same pitch, it is understood that R is proportional to Z. If this statement is there, equal pitch, okay, then R is proportional to Z. So see the relation. RD can be written as RB plus 2 times of RC. So this distance from here to here, this distance can be written as RB plus 2 times of RC. So R is proportional to Z, so it will be ZD equal to ZB plus 2 times ZC. Okay, so that is written here. So given in the question that approximately DD is 228 mm. So we have seen that pitch circle diameter is equal to module, product of module and number of teeth. Okay, so this is the formula to calculate the pitch circle diameter. One of the formula to calculate the pitch circle diameter. So D is equal to M into ZD. Substitute the known values. So as of now, whatever the approximate value is given in the question, we will substitute that. So ZD is equal to DD by M. Module is given. The approximate diameter is given. 228 by 4. The answer will be 48 teeth. So this is 48 teeth. Here. So this is approximate, not exact, because the diameter what you have taken is approximate diameter. So answer what you are going to get is approximate answer. So now for time being, we will take this as the value, that is the number of teeth in D, to solve further. So we will keep this as it is. We will go to calculate the speed. Okay, so take the tabular column. So same type of table is prepared. Condition of motion RVA, RB, RMC, RU. See, C is the same gear of same size. Okay, so no need of writing it 3 times. Here it is same property. The gear is having same property, so the speed will remain same. So one column is sufficient for that. So no need of drawing it 3 times. Okay, so first step, fix the arm. Fix the arm in the sense, fix the spider A, give one rotation to any one gear. So here either you can give for any gear. There is no compound gear here, so the choice is yours to give the rotation. I will give it to gear B. So I will give the rotation to gear B. So when you give the rotation to gear B, it will have plus 1 rotation and it will be a driver for remaining gears. Clear? So now B is a driver. So next gear C. C is in mesh with B. So B is a driver for C. So it will be number of teeth in the driver gear to number of teeth in the driven gear. So it will be ZB by ZC. Driver to driven. And their direction of rotation is opposite. So we'll put a negative sign. Next, coming to gear D. So D is in mesh with C. C is in mesh with B. So all three gears has to be taken into consideration. We will start from BC. Okay, B and C are in mesh. So B is the driver for C. So number of teeth in the B to number of teeth in the C. So it is ZB by ZC. Okay, their direction is opposite. So put a negative sign. So this is the relation ZB by ZC. Next pair is C and D. They are having internal mesh. Okay, so C is the driver for D. So it will be ZC divided by ZD. Since you have internal meshing, there is same direction of rotation. So no need of putting negative sign. Clear? So multiply these two relations ZB by ZC into ZC by ZD. So here ZC get cancelled. Negative positive negative will remain, so remaining is minus ZB by ZD. This is the first step. Okay, so writing the speed value. Second step, multiply x, in the previous case 0 1 into x minus ZB by ZC into x minus ZB by ZD into x. Third step is adding y. Add y to all this. 0 plus y is y plus x, y minus ZB by ZC into x, y minus ZB by ZD into x. Okay, this is the tabular column method to calculate the speed. So last table, last line, what you get, these four equations, they are the speed equations of the respective elements. Okay, now in the problem he has asked to calculate which speed, solve that equation. So this problem he has asked to calculate the teeth. And next he has asked to calculate the diameter. Clear? So we are not much depending on the equation, but we need that equation to find that diameter here. So for that we will make use of the statement given. So in the question he has told that spider A makes one revolution for every 5 revolution of sun wheel. That's sun wheel B. Okay, so that means what is the speed of A? We have y. From the table we got y. So if it is equal to 1, okay, if that y is equal to 1, according to statement, for every 5 revolution of sun wheel B, what is the speed of sun wheel B? That is y plus x according to the table. Okay, so when y is equal to 1, this y plus x is equal to 5. That is the relation. So this is these two relations, these two, this one and this one we get from the statement given from the problem. Okay, y is the value we got from the tabular column, that is the speed of gear, sorry, arm A. Y plus x is the speed of wheel B. Okay, so when y is equal to 1, y plus x is equal to 5 here. So therefore substitute the value, y is 1, y plus 1 plus x equal to 5, so x you will get as 4 is the value of x. Now second part given in the question is the wheel D is stationary, wheel D is fixed. What is the meaning of fixed? It doesn't have any motion. Okay, so in the tabular column we got the equation y minus zb by zd into x. That is the equation we got for gear D. Now equate that equation to 0. Since it is fixed, we are equating that to 0. Okay, substitute the values. Y is 1. Okay, we just got here. ZB, ZD is unknown for us. Okay, X is here. Just now we got, equate that to 0. So when you solve this, we will get this relation. ZD is equal to 4 times of ZB. Okay, so this is the relation what we got. So keep it as it is. We will consider the approximate number of teeth what we got in the first step. Okay, initial part of the problem we got the approximate number of teeth that is ZD is equal to 57. Okay, substitute that here in this particular relation. So we will get, therefore ZB is equal to 57 divided by 4. The answer is 14.25. Okay, so this answer is approximate answer again. See, you are using 57, which is an approximate value. So using that, the answer what you calculate, that is also approximate. So we need to calculate the exact number of teeth. So what we have to do is, we have to do a trial and error method now here. So to get the values, exact values, we have to do trial and error method based on this answer. Okay, based on this answer, we have to assume different values and we have to solve the problem. Okay, we got 14.25. Let's take the case 1 first. Try. Okay, case 1. So let ZB is equal to 15. So we got 14.25. I will take the next nearest number, that is 15. Now substitute ZB as 15 in that case. Okay, substitute ZB as 15. Go in the reverse order. Now calculate ZD. Okay, we have the relation ZD is equal to 4 times of ZB. So 4 into 15, you will get 60. Now the first equation. In the first equation, the relation was ZD equal to ZB plus 2 times ZC. The first equation. Now substitute there. Okay, the whatever the answer you got, you get ZC as 22.5. Here, there. So we know that a gear can't have a decimal number of teeth. Can you have 22.5, 22 plus half teeth? That is not possible. Okay, so what we can do is, what we should get is, we should get a whole number, either 22 or next 23. We can't have 22.5, 22.75, like that we can't have. Okay, so this first iteration, first answer what we got, this we can't use since we have fractional. So we'll go for case 2. So what was the answer there? 14.25. We will go behind. We will take 14 as a value. Okay. Suppose ZB is 14. Assume ZB is equal to 14. Do the same thing. ZD is 4 times of 14. 56 is answer. Again take the equation 1. Substitute the values. 56 is 14 plus 2 times ZC. Now you will get ZC as 21. So you will get a whole number here. Okay. So no decimal place. So since we get a whole number 21, so this can be taken into consideration. So this is the exact answer. 21 is the number of teeth in C. So you got this 21 when you took B as 14. So here that is a final answer. ZB is having number of teeth as 14, ZC is 21, and ZD is 56. So the second case, what is the answer you got, that is a final answer. Now take this into consideration, we have to calculate the diameter. So go in the reverse order. So we got the relation dV is equal to m into ZD. So here m is given in the problem 4. 56 is the answer you got here. Substitute that. 224 mm is the exact diameter, thick circle diameter. So in approximate it was given 228. Exact answer is 224 mm. So this is the final diameter. So first part of the problem we have finished. Okay. Second part is to calculate the torque. So we have the relation TB NB plus TA NA plus TD ND is equal to 0. That is the energy equation. Okay. So where T is the torque, N is the speed. So only three are considered here. As I already told, the input, output, and the fixing member. Fixing member means the arm. So the center B, that is the first gear. External D is the output gear. So all these are uh, fixed with the help of arm A. Okay, so B is considered, A is considered, D is, C is not considered here. Here, so this is how you really write the relation for the torque. Here, so substitute the values. So TB, NB, TB is given in the problem, NB is given in the problem, TA is given in the problem. Sorry, we have to calculate that. NB, NA is given. Since D is fixed, this D is fixed, ND is 0. Okay, so the third term remains a 0. Substitute the values. 30 Newton meter is given. Speed of B is 5. Torque of TA we have to calculate. Speed of A is 1. So answer you will get as minus 150 Newton meter. Clear? So now for the spider A we got the torque. Now we have to calculate the torque for member D. So in equilibrium we have the relation TV plus TA plus TD equal to 0. I told the equilibrium condition the sum of torque has to be equal to 0. Substitute the values. So 30 is the torque of gear B, minus 150 you just now calculated, plus TD is equal to 0. So that will give you the final torque on the fixed gear, that is TD, equal to 120 Newton meter. So this completes the problem.